Hello students, let's begin the chapter sets. The concept of sets is very important in various fields of mathematics. In this chapter, we discuss some basic definitions and operations involving sets. In our daily life, we often speak about various collections, say the collection of cricket team, pack of cards, etc. All these are examples of collections. In mathematics also we have collections, but mainly these collections involve numbers. For example, consider the following collections: odd natural numbers less than 10. In that collection you can see the numbers will be 1, 3, 5, 7 and 9. All these numbers are odd natural numbers and they are less than 10. Then second collection, rivers in India. Then next one, vowels in English alphabet, that contains A, E, I, O, U. Then various kinds of triangles, and the last one, prime factors of 6. So prime factors of 6 includes 2 and 3. Okay, so all these are collections. If you consider the first collection, that is the odd natural numbers less than 10. In that collection, we can say whether the given number belongs to that collection or not. If I take 7, you can see 7 is an odd natural numbers which is less than 10. Okay, so 7 is an element of that collection. And if I take 2, you can see 2 is not an odd number, that is natural number and less than 10, but it is not odd, so 2 is not an element of that collection. And if I consider the second collection, rivers in India, you can see Ganga is an element of that collection. And if I take Nile, you can see Nile is not a river in India, so that does not belongs to the collection. So if you consider any of these 5 collections, we can say whether the given element belongs to the collection or not. Okay, so we call such collections as well defined. Well defined means we can say whether the given element belongs to the collection or not, and such collections are called sets. Okay, so we can define a set as a well defined collection of objects. We can say well defined collection of objects. That is the definition of sets. Then consider the following collections. Say the first collection of 5 most renowned mathematicians of the world. That is a collection actually. It contains mathematicians of the world, 5 mathematicians of the world. But is it a well-defined collection? Can we say the given mathematician belongs to that collection? We cannot say that exactly, because that varies from person to person. So it is not a well-defined collection, and hence it is not a set. In order to be a set, it should be well-defined and collection. Okay, well-defined plus collection, then only it should be a set. Now we can look at some basic ideas of sets. Okay, so the terms in that set are called elements, objects and members. 3 names are there: elements, objects and members. Then the sets are usually represented by capital letters. We can use capital letters, say A, B, C, etc. Okay, so sets are represented by capital letters A, B, C, etc. And elements, objects or members in that sets are represented by small letters. We can take small letter A, B, C, etc. So sets are represented by capital letters and elements are represented by small letters. Now let's look at the representation of few sets. Okay, so the symbol or the capital letter N is used to represent set of natural numbers. So we know that natural numbers includes 1, 2, 3, etc. And the collection of whole numbers, they are represented by capital letter W. So W means that is the set of whole numbers, and the set of integers, they are denoted by Z. Okay, so Z is used to represent the set of integers. And we can see there are positive integers, negative integers and 0. Okay, so the set of positive integers are denoted by Z plus. Okay, so Z plus means that is the set of positive integers. And similarly, the set of negative integers, they are represented by Z minus. So Z minus is the set of negative integers. and 0 is not a positive integer and negative integer. Okay, so positive integers includes 1, 2, 3, etc., and negative integers includes negative 1, negative 2, etc. And the set of rational numbers, it is represented by the symbol q. Then q can be like there are positive rational numbers and negative rational numbers. So q plus for positive rational numbers and q minus for negative rational numbers. Then the last collection r. R is used to represent the set of real numbers. So real numbers are represented by capital letter R. So these are some representation of sets. Okay, natural numbers, whole numbers, integers, rational numbers, and real numbers. Now we can move on to a representation of set. Okay, so suppose a is an element of a set, say capital A. Small letter a is an element of a set capital A. Then we can say that small letter a belongs to capital A. Okay, and we can write that using a symbol epsilon. Epsilon, that is a Greek symbol. We can represent that as a belongs to capital A using epsilon symbol. Suppose B is not an element of the same set capital A. Okay, so B is not an element of capital A. Then we can say B does not belong to A. Okay, B does not belong to A, and this can be represented by crossing out that epsilon. Okay, so B does not belongs to A. This is the representation. Okay, so we can represent whether the element belongs to or does not belongs to the collection using epsilon symbol. Consider the other collection, set of vowels that contains the letters A, E, I, O, U. Then you can see A belongs to that collection, and B, or we can say take H. H does not belongs to that collection V. Okay, you can represent that using the symbol epsilon. Now we can move on to representation of sets. There are two ways to represent a set. Okay, so the first way to represent sets is using roster form or tabular form. We can say roster form or tabular form. In order to write the set in roster form, we have to first list the elements of that set. Then they are separated by comma, and you can see they are enclosed within braces. This bracket is called braces. Consider the collection of all even positive integers less than 7. Okay, so the numbers in that collection will be 2, 4, and 6. So you have to write that inside a braces. So you have to write that bracket, then write the numbers separated by commas. Okay, so this is the required roster form. Now let's look at the second problem. Suppose you have to list the natural numbers which divide 42. So the numbers which divide 42 are 1, 2, 3, 6, 7, 14, 21, 42. These are the natural numbers which divide 42. Then you have to write inside that brace. Okay, inside that bracket. This is the method. Now we can move on to another collection. Okay, so we can take vowels in English alphabet. So consider the set of vowels in English alphabet. Okay, so what are the vowels in English alphabet? We know that they are A, E, I, O, U. So you have to separate their letters by comma and write inside that bracket. So A, E, I, O, U. This is the roster form of this set. Okay, now consider one more set. Suppose take odd natural numbers. So if you take odd natural numbers, so that should be natural numbers and odd. Okay, so odd natural numbers include 1, 3, 5, 7, 9, etc. So this is infinite collection. Actually, the infinite number of elements are there. So you can write like this. Okay, this is the method. Now we can move on to the second method of representing sets. Okay, so the second method of representing sets is using set builder form. Okay, so the second method is set builder form. From the name itself, we can see we can write the set from that form. Okay, that is set builder form. We can build the set from that definition. So all elements in a set has a single common property which is not possessed by any other element outside the set. Consider the collection in roster form. So you can see the set of A, E, I, O, U. So you can see all letters are vowels in English alphabet. That is a common property of elements in this collection. Okay, so we can define the set as set of all X such that X is a vowel in English alphabet. So you have to write in this form. Okay, so this can be, you can read this as set of all X such that X is a vowel in English alphabet. Okay, so this is the set builder form of sets. Okay, so there are two ways to represent set. One is using roster form and the second one is set builder form. Okay, in set builder form you have to write in words, and in roster form you have to write the elements separated by commas inside that bracket. Okay, now consider one more collection. So let A be the set of X such that X is a natural number. So you can take X is a natural number and 3 less than X less than 10. Okay, if you consider the set of all natural numbers with a restriction 3 less than X less than 10, that means that natural numbers should be in between 3 and 10. So in that collection the numbers will be 4, 5, 6, 7, 8 and 9. These are the only natural numbers that lies in between 3 and 10. So this will be the required set. The first one is set builder form and second one is roster form. Now we can do some problems. Write the solution set of the equation x squared plus x minus 2 equal to 0 in roster form. So for that, first you need to find the value of that variable, that is the solution set. So here you can see the product is negative 2 and sum is positive 1. So you have to identify the numbers with these two conditions. So it is easy to find out that numbers. The numbers in this case will be product is negative 2 and sum is 1. So you can take 2 and 1. Since the product is negative 1, you can take negative 1 and 2. Sum is positive, so the largest number should be 2. Then you can write the given equation as x squared plus x minus 2 equal to 0. That is given. You can write x as negative x plus 2x. Okay, so x squared minus x plus 2x minus 2 equal to 0. Then you can take x from the first two terms, so that becomes x times x minus 1 plus 2 times x minus 1 equal to 0. Then you can take x minus 1 common outside, so it will be x plus 2 times x minus 1 equal to 0. So product equal to 0 means either x plus 2 equal to 0 or x minus 1 equal to 0. If you equate x plus 2 to 0, you will obtain x equal to negative 2, that positive becomes negative. So x equal to negative 2 or x equal to positive 1. So the solution of this equation are negative 2 and 1. The problem is to write the solution set in roster form. Solution set includes the numbers negative 2 and 1. Then you have to write in roster form. So you can write that bracket, then write negative 2 comma 1, then close that bracket. Okay, so this will be the required roster form. Okay, so hope you understood this problem. Now we can do another problem. Write set of all x such that x is a positive integer and x square less than 40 in roster form. Okay, so we have to identify the positive integers whose squares are less than 40. If you take 1, you can see 1 squared, that is 1. So 4 less than 40, 2 squared is 4 less than 40, 3 squared is 9 less than 40, 4 squared that is 16 less than 40, 5 squared 25 less than 40, 6 squared 36 less than 40. But if you take 7 squared is 49, so that will not be in this collection. So this is the required set. Now we can do another problem. In this problem, you have to write the given set A equals set of all 1, 4, 9, 16, 25, etc. in set builder form. So first you need to identify the common property. You can see all these are squares. We can say squares of natural numbers. Okay, so you can write A in set builder form as set of all x such that the set contains all x value such that the condition is x is the square of a natural number. So natural numbers, you can see 1 square 4, 1 square 1, 2 square 4, 3 square 9, 4 square 16, etc. That is given in that collection. Or you can write this as A equals set of all x such that x equal to n squared, where n is a natural number. So we can write where n belongs to capital N. We can write either in the first way or using the second way. Okay, both are correct. Now let's move on to the other problem. Write the set of all 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7 in set builder form. So you have to identify the common property. You can see that is that contains the set of all x such that x is in the form n by n plus 1. The denominator is 1 more than the numerator, and the numerator, you can see the numerator is a natural number. Numerator means n includes 1, 2, 3, etc. up to 6. So n belongs to capital N, and we have the restriction n should be in between 1 and 6. So the values 1 and 6 are included. So we can write 1 less than or equal to n less than or equal to 6. Okay, so this is the required set builder form. So set of all x such that x equal to n by n plus 1, where n belongs to capital N, and 1 less than or equal to n less than or equal to 6. This will be the required set builder form. Okay, now move on to another problem. Write set of all x such that x is a letter in the word principal. Okay, so you have to write in roster form. So you have to write the letters P, comma R, comma I, comma N, comma C. We already wrote I, so we can skip that. The next letters are A, comma L. Okay, so in this video we have discussed the methods of representing sets and some definitions of set. Okay, then see you on another video. Hope you understood this method. Thank you.